All right, the purpose of today's activity is for us to examine how to build a stable atom. So this looks really familiar. We've looked at this website before, the Build an Atom simulation on PhET. Go ahead and click the link that's there. It'll take you to this web page. You can push play, build, and go left. We can figure out this animation. So one of the key things here on the bottom, you guys can notice down here it says element, neutral ion. We can put element, neutral, stable. We can make mass number, mass charge, why not? And we could just start throwing things in here. So right now we have one proton by itself. Oh, something interesting. Kind of just playing around with this. It's just some time for you guys to examine these things and kind of detect more rather than the charge. We're going to be looking at more of the stability of the element. So based on playing around that for a little bit, I want you guys to answer the following questions. So explore the Build an Atom simulation with your group. Unfortunately, that's by yourself. As you explore, talk about what you find, make sure you have the following settings. So kind of as shown in this picture, like I just went through, answer these 6 questions. So you'll go through those 6 questions. Notice that down here, this chart is showing the number of neutrons on the y and the number of protons on the x. This line right here is like y equals x, 1-to-1 kind of ratio. And then there's like these dots that kind of show something there, maybe the nuclear stability. So once you've done that, or once you have gotten to that website, go ahead and answer those 6 questions, and then pause this video and answer those 6 questions. Excellent. So I'm assuming you've figured out those 6 questions, come on back and we'll take a look at this second part, number 7. It says use the chart to the right to determine if the atoms listed below are stable or not stable. And if they are not stable, what will happen to make them stable? So there's 3 things or 3 ways in which an atom is not stable. So you may have noticed the y equals x line, the 1-to-1 proton to neutron ratio. And then all these dots, I don't know if you're able to figure this out and guess, all these dots are stable isotopes or stable ratios of neutrons to protons. So like if I had 30 protons, 40 neutrons, that would be a stable isotope. If I have something that comes over here, so let's say I have 80 neutrons and 40 protons, I'm in this range of here. This is going to be unstable. So if I have this unstable, we could say how would I make that stable? Well, I could either gain protons, because if I gain protons, it's going to take this kind of dot. It's going to take this dot and move it over into the realm of stability. So it would kind of take this thing, if I gain protons, it would look like that, or if I lose neutrons, it would kind of go that way. So if you're in this range, you could gain you could gain protons. Gain protons or lose neutrons would get you to the realm of stability there. So let's say you are in this range up here where you have B. That means you have way too many neutrons. What could you do to get that to a realm of stability? You could lose neutrons or lose protons. That would get you kind of back into this range. And then let's say you have some kind of ratio where you're in the C range. You could either lose protons, which would get you back this way, or even if you're down this way, you could gain neutrons. So just some ways to kind of make neutrons make isotopes stable when they're unstable. So I just want to do a couple examples with you guys. So this very first one is mass of 14, atomic number of 6. This is atom carbon. So remember, mass number is protons plus neutrons. This is the atomic number, which is the number of protons. So if I was thinking, this is 8 neutrons. So 8 protons, I'm sorry, 6 protons, 8 neutrons. Looking down here, it's kind of hard to see, but this is like a 1-to-1 ratio. So if I was to have 8 neutrons and 6 protons, it's going to kind of get me right above that range. What could I do to make this stable? So you're going to say unstable. And I need to make this dot move down. So I can make this dot either move down by losing neutrons, or if I gain protons, it would kind of get you into that realm of stability. So either way, you could say, I want to have it gain protons, or you could say both, actually. You could gain protons or lose neutrons. So it's two ways to kind of get you back to that realm of stability. If I'm looking here, I have 20, atomic number of 20. That would bring me down to this point here. I have the atomic mass, or mass number, of 40. So remember, protons plus neutrons gives you that, so you'd have 20 neutrons. So I'm looking at this, I'm kind of at this 20 to 20 range. It's kind of in that realm of stability, which is all these dots, all these different isotopes are representing. So for this one, I would actually say stable. The last of the three I'm going to go through, and then I'll let you guys do the rest, is this 110 and 40. So in going through this, 40 is the number of protons. The atomic mass, or mass number, is 110. So I can figure out the number of neutrons is 70. So if I was to use this 70 neutrons and 40 protons, let's see where I'm at here. So I have 40 protons. I'm going to draw the line up to 70 neutrons. I'm kind of in this range right here. And you'll note that that is not stable, because anything in this range right here is going to be stable. So any of these dots here are going to be the realm of stability. If I'm not along those dots, it's not stable. So this one is going to be unstable. And so if I'm looking at this, what could happen in order for this thing to become stable? Well, you can take this and do a number of two things, like we kind of said earlier. Right here, you could either lose neutrons to get back down to this range, or gain protons. So I'm going to write the same thing. You could either gain protons or lose neutrons. So if you're in this range, you could gain protons or lose neutrons. If you're up in this range, the element is just too big. You'd have to lose neutrons and protons. Not necessarily neutrons and protons, but neutrons for sure to get you kind of down this range. If you're over here, then lose neutrons and protons. If you're in this range, over here, the best way to kind of become stable is to lose protons or gain neutrons to get you kind of in this range here. So let me know if you guys have any questions. Hopefully that was helpful. I'll talk to you later.